All right, these are the 10.2 notes for trig. You'll need your unit circle today, so make sure you have that handy. We're going to talk about converting from rectangular to polar coordinates and then back from polar to rectangular. So rectangular is what we've been working with always in math, the x's and y's. And the polar is going to be an r and a theta. So the r represents the radius or the distance, and the theta represents the angle or the direction. We have 4 equations that are going to help us solve these, convert these over, depending on which direction we're going. So for example number 1, it says convert each polar coordinate into a rectangular coordinate. Express your answer in simplest radical form. So I have an r and a theta, and I want to take that to an x and a y. So if I have an r and a theta, I want to use this one right here that has the r and the theta, as well as that one right there. And if you can see, that's going to give me an answer of x and an answer of y. So these are going to be a 2-part problem. We're going to find x first, and we're going to find y second. All right, here's how this works. We're going to plug in the 6, and then cosine of the pi over 6, the angle. And I'm going to do that same thing over here, 6 sine of pi over 6. And cosine of pi over 6 and sine of pi over 6 we can find on our unit circle. So I'm going to flip over to my unit circle. And here's pi over 6 right here. And I've got the sine and the cosine here and here. Cosine is the x, sine is the y. So we'll just take those two numbers, radical 3 over 2 and 1/2. And this will go for the x, and this will go for the y. And then I'll just go ahead and bring this 6 down. Since I have fractions there, I'm going to write 6's as fractions. And now what I'm going to do is cross cancel. So I notice a 6 and a 2 diagonal from each other. This works as long as you have 1 in the numerator and 1 in the denominator. I know both of those can be divided by 2. So I'll change that, divide that by 2 to get 3. Divide that by 2 to get 1. Do the same thing over here, 3 and 1. So that leaves me an answer of x equals 3 radical 3 over 1, which I don't need. And y equals 3 over 1. Again, I don't need the 1. Because our problem, was originally as an ordered pair, we're going to write our answer as an ordered pair. So 3 radical 3 for the x value and a regular 3 for the y value. There we go. If you don't want to cross cancel, you can actually divide at the end. I just find it a little bit easier to cross cancel. Let's look at the second example. Again, we have our r and our theta because it's in polar form. So we're going to use the same 2 equations. I'll start by immediately plugging them in. 5 cosine of 0 and 5 sine of 0. As you look at your unit circle, 0 is this 0 right here. That's what they're talking about. So we're going to have cosine as 1 and sine as 0. Cosine of 1 and sine of 0. So that one ends up being a lot easier of a problem. X equals 5 and y equals 0, which would give me the point 5, 0, which is a little bit strange because it actually ends up being the same exact point. But whether you're graphing in rectangular or polar, you just move 5 places over to the right, or if you're graphing in polar, 5 rings out. All right, example number 3. It's going to be a little bit more complex. Still going to be using those same 2 equations. So x equals 4 square root of 2 cosine of 7 pi over 4. And y equals 4 radical 2 sine 7 pi over 4. So same equation, just x is cosine, y is sine. All right, so I'll leave the 4 radical 2. Now I'll go get the answer for cosine of 7 pi over 4 as well as sine of 7 pi over 4. So switch over to your unit circle. 7 pi over 4 all the way down here. And you've got the x and the y. Notice the only difference is the y is a negative. Sign is a negative. So radical 2 over 2 and negative radical 2 over 2. And this is all multiplication. So we'll put those over 1. All right, I'll start by cross-canceling. I see this 2 in the denominator and the 4 up at the top. I can't cancel any of the square roots yet. So go ahead and do the 2, divide that by 2, divide the 4 by 2. Do the same thing over here. And now what I'm going to do is I'm going to take the 2 square roots and bring those together. Square root of 2 times square root of 2 is a regular 2. In other words, the square root of 4, which simplifies down to 2. And so now in the numerator, I have this 2 on the outside times that 2, which gives me 4. And 1 times 1 over 1, which is not needed. Same thing happens right here. I'm going to multiply these two together. I'm going to pull that negative out kind of in front. Just ignore it for the moment. Make sure my answer is negative. But again, 2 times 2, as long as they're both square roots, would give me, sorry, not the 4, square root of 4, which would give me a 2. So 2 times 2, 4, and then you have that negative there. All right, so we write our answer as an ordered pair because that's how they gave us the problem. Something like that. All right, example 4, this is a good time to pause and try this problem on your own, just to make sure that you can do it. All right, hopefully you got a chance to try example number 4. Here's what we should have. 8 square root of 3 times negative 1/2. And 8 square root of 3 times square root of 3 over 2. I'll put those under 1. I'll cross cancel the 2 and the 8, dividing each of those by 2. Then here I have a 4, a negative 1, and a radical 3. I'll write that as negative 4 radical 3. And for the y, these 2 radical 3's come together to make 3. And then 4 times 3 makes 12. Write your final answer as an ordered pair, and you're done. All right, so that is going from polar into rectangular. So going from an r theta into an xy. And on the back side of the notes, we have the opposite direction. So they're going to give us the x and the y, and we're going to try to change it into an r and a theta. All right, so we've got the formulas on the back, just to make it easier to see. This is the x and the y. So we have to plug it into the formulas that have both the x and the y. X and the y. So we're going to be using these two on the right. We'll start with the r squared. We're going to want to put these in parentheses, especially since you've got a lot of negatives. Negative 1 squared is 1. Negative radical 3 squared actually gets us 3. The negatives cancel out. Negative times negative is positive. And then the square root of 3 times the square root of 3 gets me 3. Right, so then I have, bring this down, 1 plus 3 is 4, and I'll need to square root that at the end to get r equals 2. So that's my answer for r. Now I got to go find theta. So just like before, we have to find it as 2 separate problems. So tangent of theta equals y over x. So I'm going to take the y value, put it over the x value. And then I'll simplify this a little. A negative divided by a negative is a positive, so I could get rid of the negatives. And a 1 in the denominator doesn't do anything, so I have just radical 3. Now, here's a slight problem. When we go to our unit circle, there's actually 2 places on the unit circle where theta, the angle, is radical 3. It happens right up here. Oops. And then it happens down here in this bottom corner. So we need to figure out which one of those is the correct answer, either pi over 3 or 4 pi over 3. And the way we do that is we do a miniature sketch of the graph just to plot this point. So think about the point -1, negative radical 3. If I was going to plot that on an XY graph, which quadrant would it end up in? It doesn't have to be an exact number. You don't have to change anything to a decimal. You're just going to say, okay, if I'm going -1, it's to the left. And if I'm going negative radical 3, it's down. So a negative would put you in quadrant 3, which means your answer then has to come from down here. So our answer is going to be 4 pi over 3. And you'd write your answer final as an ordered pair. And there we go. All right, let's try example 6. All right, so we'll have r squared equals 5 squared plus 5 squared. And that's 25 plus 25. Add those together to make the 50. And square root. Now, when you square root 50, just a reminder on how to simplify. I do believe, as I was looking at delta, that it does accept the square root of 50. But I just want to make sure that everybody knows how to simplify radicals. So you break this down into a factor tree of 25 times 2, or 5 times 10 if you prefer. And then you break 25 down into 5 times 5. Any pairs are going to go on the outside. Any single goes on the inside. So 5 square root of 2 is the same as the square root of 50. That's a good skill to have. All right, then we have the tangent is y over x. Make sure you put it in that order. For this one, it doesn't matter because x and y are the same. And then we simplify that to get 1. And as we look on the unit circle, notice that there are 2 locations where your value is 1, down here as well as up here. So we just got to figure out which quadrant that point would be in if we plotted it. So 5, 5, positive, positive. You go forward and up. That would put you right here in that quadrant. And so that means our answer is going to be here, pi over 4. We'll write our answer as an ordered pair, 5 radical 2, comma, pi over 4, r and theta. The distance and the direction. Example number 7. -6 squared plus 2 radical 3 squared. In order to do that 2 radical 3 squared, we want to think about it as 2 squared and radical 3 squared being multiplied together. So that's going to give me 36 plus, and this gets me 4 times, and the square root and the square can cancel, giving me a 3. So 12. (36 plus 12) gets me 48. And remember, we do have to square root that one at the end. Let's see, 4 times 12, I know is 48. And then 4 breaks down into 2 and 2. 12 breaks down into 4 and 3. And 4 breaks down into 2 and 2. All right, so that gives us a pair here as well as a pair here. We'll multiply those, 2 times 2. And then a single 3. That's going to give us 4 radical 3. Meanwhile, in your tangents, y over x, we're going to reduce or cross cancel here. The 2 and the negative 6 can reduce. Both of those can be divided by 2. So that cancels out to a 1, that cancels out to 3, and now I'm left with radical 3 over negative 3, which is on my unit circle. Again, it should show up twice, a negative version. Right here, as well as right here. So we just have to make sure that we're in the right quadrant. Let's see, negative 6 means I go left. Positive 2 radical 3 means I go up. So we want to make sure we grab the answer from quadrant 2, right up here. And that'll be 5 pi over 6. All right, let's write our answer as an ordered pair. 4 radical 3 and 5 pi over 6. Last one. Again, another good time to pause the video, try the problem, make sure that you can do it. So hopefully you got a chance to try it. R equals 2. And then for tangent, kind of ran out of room there. Sorry about that. Negative radical 2 over radical 2. Any number divided by itself is 1. So that gives me tangent of negative 1. Tangent theta equals negative 1. Let's think about where the x and y are. X is a positive, so I go forward. Y is a negative, so we go down. Puts us in quadrant 4. So on your unit circle, make sure you get the answer from quadrant 4. That would be 7 pi over 4. And there we have it, 2, 7 pi over 4 as the r and the theta.